So what we've done here is instead of trying to bring in 3 Raspberry Pis and plug them in and run them in the lab here, or getting 3 ports punched through the firewall, or 5 ports by the IT team into our lab, we're just going to create a fake data feed publisher to show you how the message bus works, and then to provide us with data that you then can pull into your database and produce your dashboards with, because ultimately that's what we want to get to. So what you would probably be doing is, on your Raspberry Pi or on your Arduino, loading in your MQTT library, producing your program there in whatever language you're working on, and exporting your GPIO pin data that you're reading out to the MQTT bus. Instead, what I'm going to show you here is, how we produce this in Python, just to create a pseudo device is what I'm calling it, so that we can actually go out and produce some data to start working with. So the first one is, again, I'm going to say this is, Python 3 code. If you're still working in Python 2, I'm going to go ahead and bash you a little bit. It's time to upgrade, but adjust as needed if you're still working in Python 2. Not very different. I think almost every library I use is capable of both Python 2 and Python 3 scripting, and will run just fine. I believe I did check that, and all of them are both Python 2 and Python 3 capable. There are some issues if you run Python 3 before Python 3.5 with some of the libraries, and Python 2 before Python 2.7. So at least make sure you're on a fairly recent distribution of Python if you're following along with the home game. Again, if you're using JavaScript, C, C#, C++, R, Scala, Ruby, whatever you're running in, you're going to have to adjust, but most of these code libraries are available for your programming platform. So what we're going to try to do, we're going to import our libraries. We're going to define some loop and callback functions. Now, we're going to go into something that is a little bit more of an advanced concept for some people that aren't used to using loop functions, and we'll describe what those are and how to use them. Then again, we've shown some of this. You have to set your broker address, where you're going to send your information to, which is the Mosquito broker. You're going to create your object, and then you're going to actually create your blind callback definitions to point to the functions we've created. You start your client loop, you establish your connection to the broker, and then we're just going to run through, create and publish some fake data, and then you end your loop and disconnect. So as we think about this, we're going to talk a little bit about what this client loop is. The client loop is a way to handle messages when you're not sure when the message is going to come in. So when you create your loop function, what you're going to do is you're going to say, hey, when you get this message in, do this with the message, right? So what we do is we create these functions. I'm going to show you an onConnect, which is connecting to the message broker, what to do on disconnect, what to do when we receive a message, and what to do with any logging. Now, I have turned the logging off in my code, but I left it in there simply because early on, when testing the code, of course, we do test-driven programming. You want to be able to look at the logs. But if I was actually using this system for something important, I, of course, would want to generate my logging messages and be able to log those off and keep them somewhere that I could review in case I had an issue. So what we do is we create a function for each one of these types of messages that we get in our loop, okay? The loop will look at send buffers and receive buffers, and it will do the functions when something occurs within that loop. So what you're allowing this to do is you're actually starting another thread to handle the loop functions, and your program continues to run, but when something occurs in this other loop, then your code actually tells it what to do with that trigger that happened in the message loop. So I think this will become a little clearer when we look at some actual code here. So what we're going to do is go back to our code, and you'll see the message loop come in. So the first thing you do for your loop is you have to connect to the broker. Okay, so we define where our broker is. We create an instance of our class MQTT client. We're going to give it a name. This is our Python sender. The true and false are flags you can set that allow you to persist your connection or tear your connection down. True is the default message. I added it in here just because I actually use false on the receiver message. So kind of wanted to get you used to seeing that. But true is the default. All you have to do is give it a name. If you don't give it a name, I think it even creates a SHA-1 hash and will name it for you, which actually, if you're doing a large set of IoT devices, you may not actually want it to give you a name, because it will test, it's smart enough to test that does anybody else have this name when it creates the client connection on the OnConnect, and rename it if it doesn't. So then we're going to create functions for OnConnect, for the connection message, disconnect, and in this one, log. We're not actually going to have to create the message one yet. We'll do that in the receiver version. So what I'm doing here is just setting the blind callbacks, right? So I'm attaching the OnConnect function to the client OnConnect handler. Okay, so what this says is now I've created client. That's a version of my MQTT client. I'm actually attaching these definitions of functions we're going to write. We're going to write one for OnConnect, on disconnect, and on log, and I'm attaching now those to my client instance. So you don't want to forget to do this. It looks kind of silly that you say, oh, these definitions, your client should just use them. Well, you actually have to connect these messages to your instance. Why do you have to do that? Well, I can create multiple client instances within my program and give them different names, and actually attach different messages and different capabilities and different functions to the different instances of the client, right? So I actually have to glue them together. So that's what we're doing when we set our blind callback definitions. When we go through the code, this will be a little bit clearer as to when we do this, but you're going to do this before you start your loop. So then when we start our client loop, what we're saying is take this broker and basically take it and make it go listen to this loop. And you're creating this loop in another process thread. And all a loop is going to do is sit there and listen for messages. It won't start doing that until you say, okay, client loop start. Then you connect to your broker, right? Now we're going to go in and connect to so we can publish some data. Then we would be publishing data, and when we're done publishing data, you would actually want to stop and disconnect from the broker. Stop the loop and disconnect from the broker. That way, you make sure you handle everything. So it's actually important to start it before you connect, because as soon as you connect, you're going to have messages. So if you did the connect and then you started the loop, you may miss a message. Conversely, you always want to stop and finish your message queue before you disconnect from your broker. Okay, so that's our loop. We're actually also going to do our definitions now for what we do when we receive that message. So when you get a log message, and it'll produce a log message for every message it receives. But when you define an onLog message, what that says is, here's what I want to do with my logging information when it comes out. So you can actually set the logging levels here. You can tell it how big you want the buffer to be, what to put in the buffer. Here, I'm simply taking the log message and printing it out on screen. I did this initially to set it up so I could make sure that the data I was sending out looked correct, and make sure my connection was there, make sure my disconnection was there, and capture it all into a log of just a printout there. So I just printed that to screen. What you would normally do here is send it to your logging device. Okay, so that's the logging message. We just define a simple function. Mine doesn't really do much of anything except print it to the screen. We also want an on-connect and a disconnect message. You don't actually have to do anything with this. If you know your system is always going to connect and disconnect, you don't have to do anything with these. I simply use it to print again a message. Did I connect? If so, print connected. Otherwise, print what my result code was if I failed. So if RC comes back 0, I connected properly. Go ahead and print I've connected. Otherwise, print I failed, and the code was, and it can be like 1 through 9 with various messages. If you didn't, authenticate properly, it requires authentication. All of those types of messages can be handed back. And then on disconnect, similarly, I'm looking for true being RC equals 0 and print disconnected. You shouldn't receive any other code. If it doesn't disconnect, it will actually wait for the disconnect message to come back. But once you receive the disconnect message, you'll always receive a disconnected message. You won't receive a failed message. You just don't receive anything back. So that's why this one's automatically set to RC0. Okay, so what am I doing inside my loop? Well, I'm just going to create some data. So this one's going to create the bandwidth data. So I said my bandwidth here was about 5 meg per second. I'm trying to produce, using the random Gauss function, a sort of a bell curve of data. I should be somewhere around the 5 meg. This way I don't get too many highs, too many lows. If I just had a random number between 1 and 10,000, 50% of my data would normally be above, 50% below. I'd get wildly inconsistent data. But if you want something that looks more real, use the Gauss function. It's a very lightweight sort of, hey, put 68% of everything within 1 sigma, and the sigma is the 100 there. So plus or minus 100, 1 sigma. It does it really quickly and comes up with some nice random numbers. So I create a string of that for y, of the integer I create using my function. I also create, I take the x in our range. I add 1 to that because x is actually 0 to 4 for x equals range 5. And I want the 1 through 5. I create a sensor string saying sensor and whatever in my x range here. So it's going to go through sensor 1 through sensor 5 here. And then I'm going to create, I'm going to publish on the topic test/BW for bandwidth / sensor 1 first time through, sensor 2 second time through. So that's creating the topic I'm going to publish to. And then the message string is simply sensor 1 : and then the value y, which was my random number, as a string. So I'm taking these strings, I'm going to print them out. Again, this is just my test-driven design where I'm actually going to read the message and make sure it looks correct. I think in the code we're going to look at, it actually puts the channel in there as well, or the bandwidth in there as well, so I fixed that later on. And then it's going to publish it. So what the client publish does is it takes the channel string, that's the topic, right, test/BW/ the sensor number, and publishes the message string that says for this sensor, my value is whatever random number I came up with. It's going to sleep for 5 seconds, or it's going to sleep. And then it's going to go through the 5 different sensors. I do the same thing then for temperature and power, so I can create my sensor data. And then it's going to jump to the outer loop. It's going to do this 250 times, and then it's going to stop. So I wrote this just because I didn't want to drag in all my Raspberry Pis. I didn't want to set them up to actually read GPIO pins for this. I just wanted to create some Python code to create some data. So if we look at the actual data for this, I am going to drag that to full screen here. This is the code itself. Now this will all be available on our internal GitLab site if you're within Presidio. If not, not sure where I'm going to end up putting this code, but we will see if there's a way to make it available. So the first thing you do, simply import the various client libraries. So here's where we're importing the MQTT. Of course, I need time to get the sleep function, and then random number to create my data. So then I define my logging function. So we went through this before. So I define an onLog, an onConnect, and an onDisconnect message. I'm also creating something here where I'm actually watching a flag, the connected flag here. So I have to set it false because later on when I call it, I'm going to make sure it's set for true here to make sure I'm connected. Okay? So I'm just setting that flag equal to false here as one of my setup tasks. I'm also going to set my broker here to the address of my MQTT broker, which is my mosquito daemon. And then I actually create the instance of my class MQTT client, naming it Python sender and telling it use your default set of QoS and capabilities. So then now that we've made a client, we want to attach our 3 defined messages up here to that client. So onConnect equals onConnect, onDisconnect is our onDisconnect, and onLog is onLog. Again, that may seem kind of silly. We're just taking our 3 functions we defined up here, and we're attaching them to this instance of our MQTT client. So then we're going to start our loop. This is again where we've gone out and create our place to actually handle these things that happen within the message queue. So we start the loop, and then we connect to our broker, right? These are both, again, attached to the client instance of the MQTT client. Again, just a print out message just to make sure we're connecting. And here's where we're going to check that connected flag, right? And if we're not connected, so here we say while not true, and that is the connected flag equals true. So when you say while not true, so if it's false, remember up here we set it to false. So the first time through it'll always be false. Then say we're in a wait loop, right? Okay. Then as we come back around, eventually up here, we will get a connect message back where RC is 0. That means we have connected. At that point, it sets the connected flag to true. So in here, we go through here and say, aha, now it's set to true. The connected flag is true. So while not true, oh, I'm going to drop out of the while loop. So once the connected flag is set to true, it actually fails this because it is true, and will drop out to, okay, now I'm in my main loop. I do that as again, kind of a making sure everything's working. You probably don't have to do this if you're in a fairly comfortable system, but it's just a protection mechanism, if you will, to make sure you're connected before moving on. Next in here, we're just going to go through our 250 sets of each one of our 5 sensors for bandwidth, heat, and power, and we're going to create some values. So again, the bandwidth, we're trying to create a function that's, 1 sigma is plus or minus 100 of our 5 meg bandwidth measurement. Here we're looking at our heat should be about 130 degrees. 1 sigma is 3 degrees up or down. We create those message strings. And for our power, it should be 120 volts plus or minus 3.5. Why 3.5? I don't know. I chose it. It looked kind of cool. As you see here, we're actually creating channel strings. So in this one, it's test/bandwidth/ the sensor number. Right, so the first time through sensor 1, sensor 2, sensor 3. So I'm actually publishing on 5 different topics here. Test, bandwidth, sensor 1 is a topic, test, bandwidth, sensor 2 is a topic, etc. That way, when I'm taking the data in, I know which topics I've read it from, and I can use that then to put the sensor name into my time series database. As I come through here, the next one will go through these 5. Well, that's again sensor 1, 2, 3, 4, and 5. But here I'm working on test heat, right? So now I've got a different set of topics. Now I'm doing my heat topics, and I'm giving my temperature ranges out from my Y here, and I'm passing that message to test heat sensor 1 and the value of that. Come around, make another value up, test heat sensor 2. So I've actually, as I go through here, because I've also got 5 sensors for power, I'm going to publish on 15 different topics. They're all in the test. Then I've got 5 in the bandwidth, 5 in heat, and 5 in power. So I do this to put out messages that I can then subscribe to the whole just test tree, and I can pull any of these sensors out, and I know if I'm reading a voltage, if I'm reading a temperature, if I'm reading a bandwidth, and which sensor I'm reading it from. So you'll see that as we take the other side of this in, and we start to pull in the data. So finally, after we go through our 250, we're going to stop our loop, and we're going to disconnect from our server. So that's our code. That's what we're doing in this. Later on, when we run this and build this up, you'll actually see the code running, but I just wanted to go through the code we're using to create the data and put it out and publish it to our strings, right? And again, that client publish message is the one that actually takes the topic here and puts the message string out. Okay? So next we're going to look at what the receiver on the other side looks like.